we're talking about working and writing out the explicit, I believe it said the explicit and the recursive formula for the arithmetic sequence. It tells you it's arithmetic, you just got to work your way out from there. So when I do that, knowing that it's arithmetic, that means I need to figure out my first term and my difference. When I'm given two terms as far as the arithmetic stuff, it means I'm going to use my system of equations to do some elimination, and work my way from there. So let's see, a sub n is my first term plus the n minus 1 times my difference. I'm going to use that twice. I know that the 20th term is negative 1907. So the 20th term is negative 1907. That is my first term plus 19 times d. Everybody okay with me writing it as 19d right off the bat?
Yes.
Okay. Same idea with the 33rd term. It is negative 3207. Did you write it down wrong?
I wrote 23 instead of 20, and so if I was 22 instead of 19.
It's usually something silly like that. And then you get plus 32d. We now have a systems of equations to work with, which hopefully doesn't look so scary. When I go to subtract all this out, what is that then? 13?
Negative 1300 equals A1 plus 13D.
What is it, 1300?
Yeah.
So you wind up with negative 100 for your value of d, which means you can substitute in rather quickly to get your first term. If I just go back to this part here, what plus negative 1900 is negative 1907?
Negative 7.
Negative 7? So now we have first term, your a sub n is first term negative 7 plus n minus 1 times the negative 100. So our explicit rule, negative 100n plus 100 minus 7 plus 93?
Yeah.
Okay. Yeah.
Do you have to write it out in that form, or can you leave it where?
Yes, simplify. You always simplify out. Because now it's a really nice, easy one to graph and do that too. MX plus b, right? It's scary.
Where'd you get the 7 again?
It's first term.
Oh.
I substitute in here to get first term. And this was, no, this was,
That was
it was a negative 1907.
All right.
We're reusing that first part. Now recursive. The smoke coming out my ears on that one? So recursive rule, there are two things you write down to start with. Every recursive rule starts the same, whether it is geometric or arithmetic. If it's arithmetic, we have to add on our difference. If it's geometric, we multiply by the rate. This is arithmetic, and what was our difference? What was your first term? Yeah.
And this one just kind of confused me. Number 44 for a geometric sequence, they have they have two negative numbers right next to each other. Or does that?
That means your rates.
What happened to the
It doesn't make any sense.
What's negative 2 times 3? Well, very interesting. In this case here, I do want to remind you guys, the reason we have to write down first term for recursive is that if you have a recursive starting equation, first term was the second term minus 100, we don't know where that could have started. It could have started at 2, could have started at 8, could have started at 400,633. You have to tell you where to start at, okay? Does that make sense?
You're substituting it back to the negative 1907 equation. So
Yes, sir.
you're going to be subtracting it, wouldn't that boost the negative?
What?
Because you're subtracting by a small number.
Oh, I see the negative 100, so change it to minus.
Silly negatives. Tricks for kids. I distributed the negative 100 to the n minus 1. I got negative 100 plus 100. Negative 100 n plus 100. And then I combine like terms. At this point here, I have negative 7 minus 100 and plus 100, which gets me here. All I do is just chop that out. Okay. Are the others of the recursive stuff in the last 10 problems I'm going to look at now? Otherwise, I'm going to do a couple other examples to help set you guys up for what's going on tomorrow and Friday. Yes, ma'am.
Oh, I was just wondering if you could do one of the geometric ones.
Sure. Any particular one you want to look at?
Any of them.
Okay.
There was one I was thinking.
I've done 34 a bunch of times today, so I'll do 33. I haven't done that one yet.
Why not 32?
So in number 33, it wants us to write out the recursive and the explicit, but they give us consecutive terms.
Yes.
When they give you consecutive terms, it's nice. You can do it can be a little bit quicker to help solve for your rate. Take the 6th term divided by the 5th term. What do you get for your rate?
For 33,
Negative 5? Is everybody okay with that? So we know that our rate here is negative 5. Yeah.
Just kidding, I actually didn't have the specific time.
Oh, which one? All right, never mind. Scratch this one. We'll do 32.
Yes. I got that one.
Hey, look, they're consecutive again. Let's do the same idea.
32 was, 32, they're not so consecutive.
Oh, I quickly looked and I saw 6 and 5. Sorry. You're right. They're not.
Oh, yeah.
Our son, my oldest son that was that's in kindergarten. He had one of his books he had to come home to read. Is the I am books where they're reading, I am dog and I am bear or whatever. And it starts out with the first 3 letters of the alphabet: A, B, C, D, and E. Well, the way that it was run off, it went A, B, E, then D and C. So it was out of sequence. He goes, these aren't in order. E doesn't come after B. E comes after D. So he's a sharp kid.
It's a little genius.
He's getting there. Yeah, but he goes, it's not the next letter. So he understood place value. I was very proud of him. He already does math too.
It's going to be the new Einstein.
He's something. So in this case, we have geometric. What I'm going to do here is write it out twice.
You basically just subtract the smaller one from the bigger one.
No, you can't do that. No.
Okay.
This is the substitution one.
Yeah, you do substitution in this case. So we know that the second term is 6. So 6 is my first term times r, because 2 minus 1 is 1. You need to write it. Do the same thing on the other side. I know that the 5th term is 1296. That's first term r to the 4th. I'm going to get r by itself with the first equation, divided by, the first term, so I'm going to divide this by r. So then I take that, I get 1296 is 6 over r times r to the 4th.
Makes it r to the 3rd.
Correct. It makes it r to the 3rd when you simplify your exponents. And don't do that. So you have 1296 is 6r cubed. How do you undo multiplication again, ladies and gentlemen?
Five.
Divided by 6, you get 216, which gives you 6 for the cube root of 216.
Where's the 4
It was 5 minus 1. This was the 5th term. Okay. So if I know that my rate is 6, I can substitute that back in to get my first term, which is 1. Good. So that gives me 6 over 6, which my first term is 1. Now I have enough information to write out my explicit rule. The explicit rule for geometric is nothing more than a sub n is first term times the rate to the n minus 1. My recursive rule, oops, I wrote that backwards, excuse me, still starts out the same way. I write down a sub n is a sub n minus 1, and I have to identify first term. Since this is geometric, what do I do to the n minus 1?
Multiply it by the rate.
Multiply by the rate. So I just put a parentheses times 6 next to it. And where do we start the sequence at? You're done.
Yes, sir. Yeah.
Problems on the test like that? Yeah.
How many problems will be?
I think I have it at 14 total. But there,
Multi-step.
remember, there's a lot of problems that are really fast.
Sure, I got it. The answers are
Like
in the
6
back.
times 6, that's 36, that's fast.
Yeah, the answer's on the back.
Of the test?
Yeah.
Oh, I have to make sure to do that.
Yeah. How about the kids?
Be sure to have a couple examples of things I want to look at today.
Are we doing the non-calculator?
Should put answers on the back, but they
Yes.
should be like
The
fake answers.
The non-calculator stuff tomorrow. Non-calculator stuff tomorrow would consist of, remember the 1 plus 1 gives us 2. If you think about your name, you write your name correctly. In section 11.1, everybody hated section 11.1 because you had to write out the rules, but you were always able to figure out the next 4 terms in the sequence. You guys had very little trouble to figure that out. That was easy to do. Something like that, without writing the rule. Okay? Because when you write the rule, it's much easier to, after I started to show you how you can test your theory via the y equals button and help yourself with that. So could you write out a rule for a simple sequence? Do you know your formulas? I don't know your formulas. Tomorrow? No. Yes. But here's the thing. When it comes to writing rules on Friday, this is a great question. This can be writing rules of arithmetic or writing rules of geometric. Yes. I don't know if you'll have the equation, but
Well, I mean, we'll know.
you will know if it's arithmetic or geometric because I will say that it
They
is.
don't have to make up an equation.
No, there is no making up of equations.
Okay,
Okay?
that's good.
It's not that bad. It's fine.
This is first test. This should be easy. Yes. Going through this one more time with you guys. This top left one is your arithmetic sequence. The top right is your arithmetic series. Notice when you're working with arithmetic series, you have to know the arithmetic sequence. When we did that, we worked with both of them. Let me show you an example of that right off the bat. Sequence, series. Sum, adding up a whole bunch of them was called a series. I'm going to go right to the... I'm going to go right ahead to number 10. Number 10 says evaluate each arithmetic series described. Basically, this is asking you to do the following. Bless you. What is the sum of 11 of them? That is asking you what is the sum of 11. You're going to talk about the sum of an arithmetic series because it told you it was arithmetic. So if to start out with the sum of 11, you have to know, well, you're working with that many of them. First term plus the nth term over 2. you got to figure out what the nth term is. The nth term is going to be first term plus your n minus 1 times your difference, which means you have to calculate that. What's your first term?
19,
What's your difference?
76.
6. So it's 19 plus n minus 1 times 6. It's writing out the nth rule here. When I distribute and combine like terms, we get 6n plus 13. Good. So the nth rule is 6n plus 13. The reason that I have to do that is because in the sum of a series of arithmetic, they ask you for the 11th term. This will allow us to figure out what the 11th term is. The 11th term will be 6 times 11 plus 13. Is that 66 and 13 is...
What is 6n? Shouldn't it be 5 feet?
Wait,
Or 6, 5?
it's 79.
79. No, because no distributing.
Oh, sorry, my bad.
Okay.
Oh, one minute.
So right now this is, you had to figure out what is the 70 or the 11th term in that sequence. It's 79. Now you know everything you need to know. You get 11 because you're trying to find 11 of them. You know the first term is 19. You know that last term in the sequence is 79, and you've divided by 2. 19 and 79 is what?
98.
98. Half of that is 49. 49 and 11 is?
What?
Oh, I was adding. Times. I was adding to my head. It said 49. So the sum of 11 is 539. Notice when you're talking about arithmetic series, you still have to identify the nth term. Okay? Yes, ma'am.
But if the n is already provided for us,
It's a different problem. The different problem in this case here, that'll be when you look at 14. The sum of how many of them is 539. That's the factoring problem.
okay.
When you're trying to find n, that's the factoring problem. So if you look at 14, nice segue. We know your first term is 24. N minus 1 times 5. That gives us his nth rule. 5n plus 20. Oops, sorry, 19. Everybody okay with that? Because I was given first term and difference. Okay. If I want to figure out how many of them in this sequence I'd have to add together to have it equal 539, then I use that into the formula. I don't know how many I'm adding together. I use first term, nth term, over 2. 539 will equal n times the quantity, 24, plus 5n plus 19 over 2. This 5n plus 19 is the nth term. That's why we wrote it out. Multiply both sides by 2 to get rid of it right away, and I think you get 1078.
Yeah.
And 1078. 24 and 19 gets me 43.
Yeah.
So if I distribute the n in here, I get 5n squared plus 43 N. You okay? All right. Bring the 1078 over, so you set aside equal to 0, and then we use our calculator.
Can you bring the 1078 over?
Yep. A lot of times people are getting errors when they go to the calculator on this. They mistakenly use the negative symbol instead of a subtraction symbol, or they forget to put an X in there for the second term. That's usually what people screw up. Like you? What you said, like me? Well, now you know not to. What's wrong?
When my 11 in the X column, it comes up as 60.
You have something typed in incorrectly.
Could you guys show?
It's 5x plus 40x minus 2.
Yeah, I did.
No, it's 1078, that's why.
Oh, 1070.
If it was 1018, then you're right. 11, it would be 60, because I did that math in my head.
Okay. There we go. I got
All right. That's how you work with those two styles of problems with arithmetic. What changes with geometric is that we have to start using, sometimes when you have to find the sum of things, that's when you use the logarithm. So let's set up a geometric one and see how that works. I'm going to look at number 18. This is another problem where they're trying to figure out what is the sum of a geometric, sum of 7 of them in geometric. The sum of geometric is easier to work with because you don't have to worry about writing out the nth rule at all. What you do have to worry about is figuring out your rate. But you're given all your terms. Could you look at that and figure out what your rate is? Negative 2, good. So your rate we know is negative 2. Your rate is negative 2. Your first term is negative 4. I don't have to write out the rule because I can go right to the formula. It's not like the arithmetic one where you had to write out the nth term to make it work. So I can just do use direct substitution. I know that the sum of 7 of them will be, what is it, first term, negative 4, times 1 minus my rate to the 7th power over 1 minus my rate. Notice how I threw everything in parentheses. Correct. Just make sure you type it in the calculator like that, and you should be all right. Yes, ma'am.
Do you just do 1 plus 2, or do you not want that?
For the denominator, if you want to write the denominator as 3, that's fine. Don't do that here, because remember we talked about the numeracy of exponents yesterday? The negative 2 to the 7th power should give us a negative value. So we don't want to do that, all right?
I've actually done the minus negative, the minus and negative number, and it's given the answer.
Okay. I try not to do that because sometimes if you're not careful, you won't get it right. What are you guys getting for the sum of it?
Negative 172.
Sure. Does it look like it's the right answer?
Bird.
Okay.
Just went flying by.
Look at it.
Speaking of which, I think it was 2 days ago, a bird got in school, flew around the athletics.
First hour
hit the
geometry, a
window,
bird
died.
flew over the window and fell over.
Is that true story? Yes, it is a true
Wait,
story.
what happened?
It flew out of
No, I'm kidding, I was sitting right by the window.
I was gonna back on us. So it had a light.
It was awful,
What
everyone
did
got
we get for
Yeah.
Dinner served. negative
So it's negative 172.
I think so.
172, yeah.
Negative 172.
This is number 21.
21.
I'll show you a little bit of difference now. Number 21, it's telling you again that it's a geometric series, and you want to figure out how many of them would you have to add together in this geometric series to have it add up to equal negative 340. So in number 21, we have to find and solve for n. We're solving for that exponent now. Do the same thing we were doing earlier. We know that our first term is 4. Could we figure out what our rate is here, ladies and gentlemen?
Yeah.
What is it again? Good. So we write out the formula. The S of n is first term 1 minus our rate to the n over 1 minus our rate. Negative 340 is 4 times the quantity 1 minus parentheses negative 2 to the n over 1 minus negative 2 again. Everybody okay on that? Give me a second here. That lonely denominator, does everybody agree that it is 3?
Yes.
So can I say that I'm multiplying the stuff on the right side by 4/3? How do you undo multiplying by a fraction then? Multiply by its?
Reciprocal.
Good.
I don't get that 4/3.
Bless you.
Wait, how do you get 4/3?
4's right there.
Oh, no.
The distributive property tells you can multiply that in fractions ordering when you multiply. Well, let me ask you this: what's 2 times 3? 3 times 2. You thought about that for a second. Order doesn't matter. You can distribute things in like that, okay? Because right now you guys are saying, well, I can just multiply both sides by 3, right?
Yeah.
Then I'd have to divide both sides by 4, right?
Yeah.
And then doing the same thing. Open the door, the light goes on.
That's fancy.
Right. So time multiplied by 3/4.
Yep.
No,
we always wanted that. Nobody ever
Opposite.
Oh, no, 4/3. Isn't that funny?
Go right.
4's tiny and 3/4. That's crazy.
Why is it not
4/3?
What's the reciprocal of 4/3? It's not negative.
So if you have to switch it, it makes it negative?
You're not talking about perpendicular lines. And that's getting the opposite reciprocal for the slope.
How do you make 4/3?
You just do.
Oh, okay.
Oh, let's see. So that's 170. Half of 170 is 60. No. I don't know. What is this? What's 3/4 of 3? Now we're going to use that trick we talked about yesterday. Numeracy. Using numbers to make sense.
Oh, yeah.
What I'm going to do is I'm going to move that to the left. Okay? While I do that, I'm going to do this. To the right. Okay? Now I have negative 2 to some power is 256. What does that power have to be? Well, it's going to be positive, yeah. It has to be even. Remember, the reason it has to be even is because negative numbers raised to even powers will always give you positive values. Negative 2 squared is positive 4. Negative 2 cubed to the third power is negative 8. Negative 2 to the fourth power is positive 16. Negative 2 to the negative fifth power is negative 32, and so on and so forth. We can't do the log of a negative. So you're remembering that it's okay to use logarithm here without the negative, because your number has to be even. You can choose log. You log base 2 of it.
2, 5, 6, negative 8.
No, it's positive. I added over to here.
So you do log 2 times 2, log 2.
Log base 2 of 256, yeah.
Wait, what's like negative? Get rid of the negative.
What negative?
Need it.
There was
Oh,
one.
yeah, I think that's what it
Where?
It's gonna be positive.
What if it was a negative number?
Yeah, when you add negative 2 to 0, you get negative 2.
Yeah, so I didn't the negative.
I was just talking about it, of why I'm not worried about the negative when I'm doing the log. That's why. Then it won't work.
How do you do log again?
Base 2 to the, what's it, 6 power? Or 8? 2 to the 8 power is 256. When I have a negative or a positive 2 raised to an even exponent, it's always be a positive. If it was 2 to the negative 2 to the 7th power, then I get, or 2 to the negative 9th power, because that one would be negative 5, 28, 5, 48. No. It might be, then it means it was an odd exponent. What I'm saying here is, and this is a great question, what I'm saying here is, if this value here is negative, and this value here is positive, your exponent will be even. So when you take the log, don't worry about the sign. You're going to get an even number. If this exponent is positive and your answer is negative, your exponent will become negative. It's the only way it's going to work. Logs? No. It's 8. Because what's negative 4 or negative 2 to an 8th power? It's going to be a positive number. When you take the log, you're not worried about the negative value because, like I said, numeracy tells us negative values, odd exponent, negative answer. Negative value, even exponent, positive answer. That's all I'm saying.
And what if they're both negative?
It's not going to work. Yeah.
Log for the, if it's a negative, if the two are equal to negative number?
You can still get, you can still get a 2 to some power to be equal to negative 8. We could, well, I'm sorry, it's not going to go, I see what you're saying. Don't worry so much. What I'm looking at here is just what I want you to remember, and this is the point where it comes up. You can have a rate value that you're multiplying by negative 2 each time, that when you it means your numbers are alternating signs. It just means when you wind up on a positive, it was an even number of things being multiplied together. That's all this is saying. That's all I'm saying here. Okay? So when you get to a point you have a negative value raised to an exponent, it's giving you a positive solution. Just use logarithm like you would normally, because this negative really has no bearing upon the problem. You solve it. Okay? We don't solve logs of negative exponents or negative bases. It doesn't work. Okay? It doesn't work. And that was one of the things about logarithms and exponents that we haven't talked about yet because we haven't done that chapter. So I was just trying to show you guys one quick step here for analogy.
Okay.
Okay?
Yep.
Yes, sir.
I just have one question about the test. That, when you grade the test, like an answer was worth 4 points, and you just messed up one little thing, do you take a whole 4 points off?
Oh, of course, because I'm a big jerk. Kidding.
I was like,
Oh, you guys really thought I was that big of a jerk? Yeah, tell him I'm not that bad.
He's not that bad.
He was hesitant.
There's -6 on his to start out with. All right. Not normally.
you could be like Ms. Channel or like the other. Or you should be like Mr. Channel.
Remember. Remember. You can wish on one hand and the other. See what goes up first. It's not short.